Hello, everyone. Let's give it a few minutes, maybe a minute or two for everyone to join. Okay, let's start. It's 1 minute and 10 seconds now. So, welcome everyone. This is Rajat Krishnan. I'm the co-founder of Cloud Control, and I have with me Sanjeev Kumar. Sanjeev, why don't you introduce yourself?
I'm Sanjeev. I'm heading the product development at Cloud Control.
All right. So let's start by covering what the agenda is for today, right? So Sanjeev, why don't you take us through the agenda?
Sure, Rajat. So today, this is the continuation of our previous webinar, which we had almost like 2 weeks ago. And in that webinar, it's already available on the YouTube. You can go and take a look. What we had done was Postgres HA setup on a Kubernetes cluster running on a private data center, in this case, a Nutanix platform. The cluster was one master and three worker node, and we had set up a Postgres HA using the PG auto-failover. It was a stateful setup with three replicas, the first becoming the monitor, and other two becoming the primary and secondary. Um, to that Postgres, we had attached a PG Connect, which is a HA proxy based image. And this is to ease or kind of like make applications connection easy so that application doesn't have to switch over if the failover happens. And we had also deployed a sample Spring Boot application in that webinar and shown that how application is connecting to via PG Connect to a Postgres HA database. So we'll go into some more details as we go along. But that's the summary of the previous webinar that we had done. And today is the continuous of the same webinar where we will orchestrate Postgres failover. We will go ahead and bring down the primary, which will be the pod one in this case of the running on the Kubernetes cluster. And we will see that how the PG auto failover, which is a open source technology from Citus Data, owned by Microsoft, that switches the database to the secondary and makes secondary as primary. And the PG Connect image detects that, and the end goal is that applications remains resilient, up and running, even if the failover happens. So a lot to kind of like cover. And in this whole process, we will also show that using AdMiner, which is the PG admin interface, running on the same Kubernetes cluster, we will show that how we are keeping track of whether the Postgres node is live or not, or the PG connector is still connecting and able to service the application.
Okay, Sanjeev. So I have the architecture diagram on the screen now. So can you take us through the different components and what the role of each of these components are and how we are deploying it?
Sure, Rajat. Now, there are multiple components as we see in the picture. And all these components are running on the Kubernetes cluster that we are running. That Kubernetes cluster could be running anywhere. In this case, the Kubernetes cluster is built and managed by our product, AppZ, from the Cloud Control. And this product is completely cloud agnostic. It can run anywhere. In this case, we are running this product on the Nutanix cluster, which we are partnered with Nutanix, and they have provided a lab to us, and we are running that. And we'll show you the cluster details later. But the components, if you look from the right-hand side, as you can see that there are multiple parts. These are the stateful sets deployment of the PG auto failover. And as we are deploying three replicas, the first pod, which is the pod 00, becomes the monitor node, which keeps track of the other pods and making them either the primary or secondary. What it means is that the read write or the read only database, and keeping the synchronous replications live. That's the PG monitor node. Other two nodes would be the pod 01, which will act as the read write database, and the second would be the pod 02, which will act as a read only database. Now all these orchestration is happening by PG auto failover. So we will put a adminer front end against each one of them and show you that they are truly behaving as they are supposed to behave. Now what we are bringing here that you will see is that the simplicity by which this architecture can be easily deployed into your data center or whatever Kubernetes cluster that you choose, either on-prem or in the cloud. So that's a summary explanation of the right-hand side components, which are the Postgres running in the HA mode. As you can see, there is a pod 03 secondary. As we are running only three worker nodes, we are running only three replicas. If you have more worker nodes running, you can run more secondary or kind of like the more read-only database. That option is already available to you. You can also run this in a multi-AG format if you are running this in the cloud. Now, moving to the left, we have a PG connector, which is connecting to the Postgres HA setup, and it exposes two types of connections. One would be the read write, another is the read only. And this is a HA proxy based image, HA proxy based connector. This is provided by AppZ, our platform. And what it does is it is giving application a seamless connectivity without knowing what underlying database is in the read write mode or the read only mode. So it kind of like the protects applications, gives it a database endpoint which always remains resilient, and application doesn't need to know about where to connect to. Adminer on the top, we will have the multiple adminer screen open to show you this whole orchestration going on. And then on the left hand side, we have the application. We have deployed all the two applications, one the Spring Boot, another is the .NET. But for this webinar, we'll be focusing primarily on the Spring Boot application, which would be consuming a read write and the read only connections via the PG connector.
So when you mentioned about the PG connector, redirecting the calls to read write and read only, right? So how is it checking behind the scenes? How, and what is the architecture behind PG connector in terms of figuring out which which underlying pod to connect?
That's a good question. So this PG connector, although the HA proxy is for the routing purpose, underlying it is verifying the Postgres based the table lookup and verifying whether the database is in the recovery or it is whether it's in a standby mode or it's in the read write mode. So this is something which the Postgres natively keeps this information, and the PG connector is continuously in this case, what we have done is that we have modified the Postgres image itself, like Postgres, the pod itself it is continuously sending this information to PG Connect. Yes, I'm read write, I'm read only, and PG Connect simply configures that and exposes those type of connection on the right port. So if the database says that, yeah, I'm a read-only database, that goes in the list of the read-only PG connector connections. And at any given point in time, only one database would be read-write. And because we are doing a synchronous replication here, and that database gets listed as a read-write connection in the HA proxy configuration, which is exposed by the PG connector.
Okay, and about the cluster itself or the Postgres cluster, you're deploying it as a stateful set, right? And how is the different pods get assigned different roles?
Yeah, that's a good question. So what we have done here, and so we have taken the PG auto failover the technology from the Citus data and layer our customization on top of that, so that we know the first pod definitely becomes the monitor as dictated by the PG auto failover technology. The second pod becomes primary, and as we show you our the repository from which we are deploying this, we have added additional the layer so that you can create a database. You can also add the schema. You can also seed the database, and that database is kind of like goes in the read write mode. And the next pod, as soon as it comes, the monitor designates it as the read only, or call it like the secondary database, and it automatically sets up the synchronous replication.
Okay, so now let's go into the cluster, and then we will jump to the demo. So let's talk about the cluster that we are deploying to.
Yes, so this cluster, as you can see, there are four VMs. This could be bare metal. It is running the micro K8 version of Kubernetes, which is, I would say, like our preferred platform, AppZ. This cluster is built using AppZ with the micro K8 the version of Kubernetes. Now, on the master node, we are running certain our platform related components, along with acts as a kind of like the control plane for the Kubernetes cluster. And it is the worker node where most of the in the previous picture, most of the we saw the deployments are happening. So the three worker nodes, the one of the worker node is deploying the monitor, and other two worker nodes will be having the pod 1 and pod 2, which is the primary and the secondary databases running in the synchronous mode. With the volume configuration, everything we have simplified, and as you show, so see the repository, and if you watch the previous webinar, it's a click of a button, and our AppZ platform GitOps engine will set this up into your Kubernetes cluster of choice in the cloud, AKS, EKS, or if you want to download our AppZ platform from AWS Marketplace, you can build the cluster on the EC2 instances and run the exact same setup. Now, on the same worker nodes, node 0, 0 node 02 and 03, we have the adminer also running with the ingress controller exposing the URL, which Rajit will be logging and showing you the demo. And also the application components like the Spring Boot Java, .NET, and other applications running. Now, one more thing to mention is that our AppG platforms have built-in logging, monitoring, and observability platform as well. And we'll show you a glimpse of that as well. So as this platform is up and running, we have a Prometheus and Grafana dashboard also, which is running on the worker nodes. And you can see that how, what is the cluster health, what is the pod health, and all other details you can, Rajit is showing the Grafana dashboard. So you can watch the entire cluster health, including the pod health, from a single pane of glass.
So these are the different nodes, and you can also see the master, right?
That's correct.
Okay, so now let's log into. So if I go back to the diagram, so we want to start with the adminer, right? So we want to. So can you take us through what we are going to see as part of the demo?
So in today's demo, what we will do, and this we will be discussing the Postgres HR technology and how we orchestrate the failover. And most of the failover orchestration and the resiliency of the applications will be visible from the adminer interface, which is running on the same cluster. So we will have the 5 adminer windows. Three will be pointing to individual Postgres pods. One will be pointing to the monitor pod, which will show that how the PG auto failover is orchestrating the failover. And the second and third and minor window will be pointing to the primary and secondary. We'll also verify that only one of them is acting as a read-only database, read-write database, and other would be the read-only. Now we will have two adminer window pointing to the PG connector also to make sure that yeah, uh, they are servicing the right type of endpoint for the applications to connect to. And then we will have the application's URL, and where we will be committing the transactions and making sure the transaction is seamlessly flowing uh, through the primary and the secondary node. And in between, we will orchestrate the failover, we'll bring down the primary pod and see the secondary is getting promoted to the primary, and like do the typical failover scenario that we run into whenever the disaster happens.
Okay, so you want me to go to the adminer URL, right?
That's correct. And this is our dashboard where we have the full log of the all the deployments that has happened on the cluster. We gave a brief description of the dashboard in our previous webinar, but we won't be covering this today. Rajit is simply picking up the adminer URL that gets exposed by the ingress controller.
So I'm going to select PostgreSQL. So first we want to go to
Let's go to the monitor node first,
monitor.
monitor pod.
So that is pod number 0.
Yep.
And I'm going to get my. So do you want to talk about the adminer and how we enable the OTP?
That's a good point, Rajat. We discussed that in the previous webinar, but for continuation's sake, this adminer is running on the same cluster, and we have exposed it through the ingress. And considering that the database will be running in the private network and all, we have enabled the multi-factor authentication with the OTP also, so that only people with the right authority, right access, that means the user password plus the OTP, should be able to log into this interface because this is exposed to the web.
So I've now connected to pod 0, which is the monitor.
Let's go to the PG auto-failover database.
Okay.
And switch to the PG auto-failover schema. Now, as we can see, let's do the select node. So as we can see that it is the pointing that node pod 1 is acting as the primary, and pod 2 is acting as secondary database. And what we will so let's connect to the primary and the secondary databases individually through another adminer window.
Okay, so I'll just duplicate this, go to Postgres. So we're going to go to
Make it one,
and get my new OTP code. Okay, so now I'm connected to pod 1.
and as we can see that this is the application database. So one good thing I would again like to mention, and I definitely wants to give credit to the Citus Data, which came up with the technology, that they are orchestrating the Postgres HA using the Postgres technology. So they have built a layer on top of the Postgres technology. So monitor is acting as another Postgres instance, which is watching all other instances and make them kind of like in the HA mode. So this is the pod 1, which is acting as a application database, and we have selected the Spring Boot web database, and we have a table deployed here.
All right. So this is the application database that we're going to demo with, right?
That's correct. Yes.
Right. Okay. So I'm going to duplicate again
Yep.
and go to pod 2. I'm going to just edit the. So now I'm in pod 2 and the same table.
Yeah, and Rajat, why don't you also verify, like you have the SQL to verify that one is the read-write database and another is read-only?
Okay. So I have that. So I go to pod 1. So this is a read write.
That's correct. Yes, and that's what we expected because as the monitor says, is that pod one is in the read-write state. Let's verify the
Pod 2 is in read only mode.
good. So we are good. So the HA setup is correct, and let's open the PG Connect.
Okay. So
And let's go back to the diagram. Rajat. I want to.
okay.
So far what we have demonstrated that adminer is connecting to pod 00, which is the monitor node, pod 01 and 02. Uh, through pod 00, we verified that there are two databases as set up by the PG auto-failover. One is the primary, another is secondary. We also verified that primary is in the read-write mode and the secondary is in the read-only. So we have done this verification of like on the right-hand side. Now we are going to open two connections to the PG connector image and then verify that yeah what sort of connectivity that it PG connector is exposing against the Postgres HA setup. So let's go back to the screen now.
So I just opened a new window, a new tab, and this is connecting to PG Connect 0 to 5000.
Yes, and again, just to remind our viewer that this whole setup we had done in the previous webinar. So if you watch it, like how easy it is to deploy all these technology, PG Connect, and so you can watch that.
So that is PG Connect 5000, which is read. This is expected to be read write, right? So
Yep, and we can verify that also.
yeah, it's read write. I'm going
So
to clone
5000
this.
port we are exposing as a read-write port, and 5001 port we are exposing as a read-only port. And read-only port can also include the read-write database, which we will show you.
This is
So this is
now
the 5001 port.
5001. That's read only.
Yeah.
All
So
right.
I think at this point we have 5 adminer window open. We have connected to the individual Postgres pods to verify their current state. We have also connected to the PG Connect, two different ports getting exposed. One is the read, write, and read, and show that, yep, now everything is all set up. Let's bring up the application now.
Okay. So I'm going to go back to AppZ. So we're going to go to the Springboard, right?
Yes.
So
This is a simple UI against the account table that we have. So Rajit, why don't we commit a transaction?
okay. So I'm going to edit and make David 10 as David 11 and save.
Yep.
Okay. Saved.
Let's verify from that miner, PG Connect and PG Connect 5000 PG Connect. I just want to make sure that the data is propagated.
Yeah. So this is through the 5000 port.
Yep.
And this through the 5001 port, which is read only, right?
Okay.
Now, go ahead.
At this stage, we have the complete setup ready as if the application is live, URL is live, and now we will be orchestrating the failover. So just to give you the to
So
do the
Sanjay,
failover,
before
yeah.
sorry Sanjay, before we do that, can we show the application configuration, how the application is configured?
Yeah, yeah, that's a good point. Yeah, let's look into the application configuration. Although we had explained in the previous webinar, but I think it makes sense to explain again that how this application is deployed. So let's go to the Spring Boot repository.
So this is a public repo.
And as you can see that all the deployments, whether the Postgres HA, PG Connect, everything is deployed from Rajat GitHub account, and all these are public repository. You can go and take a look. Now, to explain the Spring Boot deployment, this is a typical Java Spring Boot application. And if you are a Java developer, you can easily see the pom.xml, the source, the database connectivity. Only one foreign file that you will see here is the AppZ YAML. So that's the manifest file that enables the deployment of this Java Spring Boot application on the AppZ platform. Now, this manifest file dictates that what base template will get used. And in this case, Rajit, you can say the Spring Boot V2, I believe we are using.
Yes, that's right.
Yeah, so Spring Boot. So this is the Spring Boot image that we are using to layer the application on top of that and deploy on the cluster. Now you can also see that the certain application properties are defined. We are, in the deploy section, we are saying that you deploy it onto certain context, which is Rajat slash dev. One replica, expose a port. So this is our manifest file, which is interpreted by our GitOps engine and deploys on the platform. Now, coming to the database properties, this application we have modified to consume two types of connection: one read write, another read only. And application is connecting to those connections offered by the PG Connect. So as I mentioned earlier, that PG Connect is offering two types of connection. One is the read write and read. Now, again, not every applications will have that, but if application is capable to consume a read write for read only connection for reporting, this type of setup is ideally suited for that. Another thing that you notice is that nowhere in the repository we are mentioning the password, how this application is connecting, because we have HashiCorp Vault running on the same cluster, which is keeping the secrets, and application is connecting to the vault to pull the secrets at the runtime. Uh, Again, to specify that we have two connections. One is the PG connector 02 going to the port 5000 read write, and the secondary is the PG connect 02 going to the 5001 as the read only. And we have also, if you look at the UI, we check the status of those connections and make sure that those both are available. So if you show the application UI, Rajat, on the top we have both the connections listed, and we are making sure both are online.
So I posted the link to the repo on the chat, so we can actually see the source code, the changes, and the history and all that right on the repo. Now, so what do you want to? Where do you want to go next, Sanjeev?
So I would say, like, at this stage, we should go and orchestrate a failover. That means that we are going to stop the pod 1, which is the primary database, and we want to see that application will remain resilient, and the switchover will happen at once we bring down the pod 1. Secondary will get promoted as the primary, and also become the read write, and there will be only one database surviving, which will provide both read write and the read only corrections to the application. So let's do that.
Okay. So Anusha, who's helping us behind the scenes, she's going to stop the Postgres in pod 1. So now, when she stops it, what is going to happen? What do we expect, Sanjeev?
So yes, that's a good question, and I would say this is PG auto failover in motion. The way the PG auto failover from Citus data, they have orchestrated this technology. So the replication will stop, synchronous replication. The the primary node, which is the pod 01, will be demoted. The pod 02 will have a new status, and there is a complete hierarchy of a status. As do you have the link for that Postgres auto failover documentation?
Yeah,
You
I'll
can
grab that link.
flash that, yeah. And they have a hierarchy of a status, and we will show you those status changing live through the PG monitor node. And the the pod 02 would go to the wait primary status. What it means is that this will pod 02 would be in the primary, also become the read write, and and kind of like waiting for the second database to come up. So this is the PG auto failover documentation, which shows that what these status have the individual meaning. And you will see that PG, the secondary database going into the wait primary status and acting as a read-write database till the database which went down comes live, and then the true switchover will happen. So you'll see all these things happening. You can take a look at these documentation, the way they orchestrate, and all these orchestrations will be happening. And you can see that this has happened. So pod 1 has been demoted. Pod 2 is in the wait primary status, and now only one database is surviving. Yeah, wait primary means is that the this node knows that there is another database, and it is waiting for that to come up so that it will start replication and designate it as a secondary. So those things also you will see as we kind of like bring up the primary pod 0 instance. Those things will be happening. You can see that the application is resilient. So Rajat, why don't we post a transaction now?
Okay. So I'm going to change David 11 to David 12, and I was able to post it. So now I'm going to go to 5000 port, reload.
Yeah.
So they just posted, and 5001. So now both are pointing to the same.
Both are pointing to the same, and let's verify that. So now go to the individual and minor window.
So here is the 5000. So this is a secondary node,
Two. This is surviving node. Yeah, surviving pod, I would say. Yeah.
right? And this should be in read write mode right now, right?
Yes, this has become the read write mode. Yeah.
So I'm going to execute. Now this has become read write.
Yep.
Now, while the other one, if I go to the node 1, they should fail right now, right?
Yes,
There you go. Connection refused.
because this database is down. That's the typical failover has happened. The secondary has become the new primary in the read write mode.
All right.
And the PG connect, both the connections are live, both are pointing to the same database, and the application is good because application is completely isolated from the failover happening at the database layer, and it is connecting to the PG uh, connect layer, which is isolating and it from the database, and it has all the connections it need to continue running.
Okay. So
Now,
now
why
what
don't we simply flash the events also, just to like
okay. So I'm going
from the
to
monitor node.
events here.
Now, here are the series of events happening, and I will not go into the details. I was like, this is the PG auto failover, their proprietary technology in motion, which is keeping track of all the databases and changing the status as kind of like the failover happens. So this is their technology in motion. They have and this is open source technology. We love it, and the reason we kind of like adopted it and put our layer on top of that, because the entire or the HA is set up using the Postgres technology only, and no other external technology is involved.
Okay.
So looking at the current status, as I said earlier, that now node pod 2 is in the wait primary, that means the read write one mode, and the pod 1 is the demoted, it is down.
Okay. So Sanjeev, what happens if now the pod one comes back up? What is expected to happen?
That's a good question. So the pod 2 has become primary read write. Now as the pod 1 comes back up, it will become the new secondary, and pod 2 will become a true primary status. So that is what is expected. So let's like bring back the pod 1.
Okay, I'm asking Anisha to do that. So she's going to start the Postgres in node 1 or pod 1. So while this is going on, the application, so the application is still continuing to use
Absolutely.
5000,
Yes.
5001,
Yes.
right?
That is what the whole purpose of this PG Connect image is it isolates from the what is happening behind the scene. Now, although in this case we have a cluster running in the same the data center, which is like in the Nutanix the lab, but the primary or secondary could be running into multi-AG format, even like the different regions. That's completely possible, and the PG Connect will be offering the right type of connection, single. And again, in this case, we have just the two. It could be possible that if there are more than two uh, pods running in different AZ or different regions, one will get promoted to the read write or primary, and all others would be designated as secondary or call it the read only databases. So
Okay. So the pod 1, the process has started. So I'm going to reload this, and you can see that. Um,
yes, as expected, pod 2 is the new true primary database, and pod 1 has caught up. And we will verify through the replication that we will connect to the pod 1 and make sure that the transaction that we posted with by making the David 12 is
so this is in
applicable.
this
Yep,
is node 2. So I'm going to log into node 1, which failed last time. So I'm going
yep.
to
Let's
log
log
in
in
now,
there.
waiting for my new OTP code. Yeah,
Yep,
it is. It's duplicated.
that's correct. So pod 1 has caught up. It is acting as a secondary. And let's verify its current status that this is in the read only mode.
Okay, let me grab the SQL. Yes, it is in read-only mode.
And other databases, we already verified that's the read write. So this is the kind of the true failover. And let's go to the application's URL. Application is still live. Let's post another transaction.
Right. Okay. So we completed a full cycle of failover, and then finally the failed node comes back up. Right.
That's correct. Yes.
So now this will repeat as if any one of the node goes down, it will just keep repeating. Right.
Absolutely. Absolutely. We can do the failback. That means like bring down the pod 2. The pod 1 again will become the primary, and the whole process will continue as.
Okay. So I have posted the Spring Boot applications link in the chat. So now let's look at the second app. We also wanted to kind of show a second application, right, which is .NET.
Yeah, let's do that. Yeah.
So I'm going to open the URL to that. So here is the Postgres application running with one node. I'm going to pull the session had expired. So I'm going to log in, and then I'm going to click on the link to the second application, which is .NET application connecting to Postgres. So this is a simple. So can you give us a background on what this application
Why
is
don't
all
you
about?
bring up the repo also? That way we
Yeah.
can explain.
Okay. I'll post the link. Let me post it in the chat as well.
Yep.
Okay. Go ahead,
So
Sujit.
this is I would say like a very sample, and we got it from the internet. So you can get that, and we have this is a sample entity framework application. And entity framework, if you're familiar with the .NET technology, it's kind of like brings the ORM, object relational mapping, so that you don't have to do the database code, the database technology. And it is also truly the database agnostic, so that you just write your code into simple .NET framework, and it you can consume any database. By default, Microsoft provides the SQL Server, and we just simply added the 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 Postgres kind of like the library to this, and make it work for the against the Postgres HA. Now, in this .NET Entity Framework application, it's a simple login application. It creates the bunch of tables on the we will show through the in the .NET database that we have created for this, and it enables the login to the application. And if you're building .NET applications, that it can be used as it is to give you a login interface and store the login data into the Postgres database. Now, this applications, since we got from the net, we haven't modified it. So it is consuming a single read-write connections. We had modified the applications to consume a read-only connections, as we did with the Spring Boot Java. So this is the application getting deployed, and Rajit will show the screen, and we will commit a transaction there.
Okay. So let me go back to the screen. So this is one of the screens. I'm just going to change phone number. Yeah, it's updated.
Let's verify it first in the through a PG Connect window. In this case, let's go to the 5000 only, because that's the port it is connecting.
Yeah.
Let's switch the database to .NET. And there's a schema too that we are deploying. So here are the tables which get created through the entity framework that we have. And we have created a new login, and Rajit updated the phone number. Let's do a update again through the application.
Change to 7. Last digit is 7 now. Saved it. Reload.
Yes.
Updated. Right.
And again, this is also connecting to the PG Connect 5000 port, and which is exposing the read write. And as the failover will happen, this application also was up and running all the time while this failover happening. So there are two applications. One is Spring Boot, another the .NET. Both applications are up and running as the failover happened, and they survived. They are completely isolated from the failover using this PG Connect image. And this shows that you can run the Postgres at a scale in a fully HA mode, and keep applications kind of like isolated and up and running in the fully resilient manner.
Okay. So now I think we completed our demo, right? So now can we
Yes.
take some questions?
Sure.
All right. So the first question is, I'm posting it on the screen. How many PG connector pods will be running, and what is the what if one dies, right?
Yeah. So PG Connect is a stateless application, and our recommendation that if you are running a stateless applications, you can have as many replicas as you want, but definitely more than two. In this case, we are running two. but depending upon that, this also depends on the load, because our ingress controller will be continue distributing the load to the different and the status applications are, you don't have to worry about syncing up the data. So definitely 2 plus, and and if you need more load, you can add more.
All right. And typically when we deploy this, one of the other question is, how do we handle different regions, right? So typically, go ahead. How we now this is running in Nutanix cluster, as we mentioned
Yep.
earlier. But if you were to deploy it in a multi-AZ cloud, how will the pods deployed?
That's a great question. So that I see two questions here. One is the multi-AZ, and another is multi-region. In the cloud terminally, multi-AZ means like within close proximity, less than 50 miles, and multi-region could be any distance. So let's discuss the multi-AZ first. Now, the AppZ platform that we built in AWS, it is available in AWS Marketplace, is set up by default in the multi-AZ format. Now, and that's a kind of like, you can say that the platform that we built from the marketplace. Now, most of the Kubernetes cluster, AKS, EKS, are also set up in the multi-AZ format that you can do. And if the worker nodes of the Kubernetes cluster in the multi-AZ format, as we deploy a stateful application through the GitOps and select the multiple replica, they will automatically get distributed in the multi-AZ format. So you don't have to worry about this. Some of these technologies are like the built-in, and you simply like inherit that as you do the deployment. And our the GitOps engine is capable to distribute the load, and you don't need to worry. Now, coming back to the multi-region, that's a different things altogether. What you have to think about here is that how far apart those regions are going to be. And ideally, you would not like, if the latency or the distance is too high, you would not like to have running them in a true, I would say, synchronous replication, because the commit time you're increase, and that will affect the applications. So Postgres does provide that you run the applications in the true HA mode in the multi-AZ, so that you're protecting against the close proximity disaster. And for the multi-region, you set up a asynchronous replication. That way, like the second region, the database is getting replicated, but not the synchronous, and it's not affecting the commit of the transaction. I hope that
Okay.
answers the question.
All right. And just I wanted to extend the question. See, when it comes to a Kubernetes cluster or EKS or AKS, right? So when the stateful sets are deployed, the pods are in different worker nodes, right? And that
That's
means that,
correct.
yeah. And the worker nodes are distributed across multiple AZs.
Worker nodes are distributed across multiple AZ. In fact, that is something that our platform also does that, and all the managed Kubernetes cluster provides that.
All right. Now, the next question is about the port mapping. I think this is kind of touches on how we are using the PG connector and how behind the scenes how these connections are managed, right?
That's correct. Yes. So to go a little deep in this case, what we have done is that the PG connector is a HA proxy based image. So it is just doing the load balancing, but it needs informations that which pod, Postgres pod to expose on the 5000, which is the read write port, and which one to expose on 5001, which is the read only the port. Now, what we do is that we have embedded a native kind of like the technology on the Postgres HA pod itself from the PG auto-failover. And what it does is that it keeps on sending the status to the PG connect on a certain port. That I'm a read-write database. Designate me accordingly, or I'm a read-only database. Designate accordingly and expose on the 5000. So that is happening behind the scene, and And as the PG connector gets those information, it has the kind of like a HA proxy, and it exposes the right database connectivity on the 5000, so that only one database is available for the read write, and there could be multiple read only databases. And this ties back to the original question that there could be a read only database in the in the multi-AG, or it could be multi-region. And PG connector can like do the load balancing. Uh, right now, we have done a simple kind of like the round robin, but it can be a weighted average. This also gives a point that at any given point in time, I can take some node, worker node, either in the same AG or the different AG as for maintenance, and the entire Postgres HA will survive. PG connector will have the right information for applications to continue working. And after the upgrade, we'll put it back in the pool, and the applications would be, it won't affect the application.
Okay. So the next question is interesting. The Postgres image that we're using here, are they custom or is it publicly available?
That's a good question. So the customization that we have done is not open source yet. That's on our roadmap to go open source, but we are not there as a company perspective. And but again, reach out to us, and we can definitely demonstrate you that how easy it is to consume that. We are already available in the AWS marketplace on and all the images. Once you establish the platform, AppZ platform, you can start consuming the images from the day one.
Okay, I think that's all the questions we have today. I think we are right on time. So before we go, I just want to quickly cover the platform. So we talked about the platform multiple times. So can you kind of give us an idea about what this platform is all about, and how this will benefit somebody who want to leverage Kubernetes in within a cloud or on-prem?
Yeah, that's a great question, Rajesh. So let me start from the right hand side. And our platform, I would say, like our platform, and as a company, we follow the Kubernetes first approach. That means that any type of client workload, we would prefer to run it on a Kubernetes cluster. Although we do support the virtual infrastructure or the bare metal as well, if that is the need from the client, and the workload that they have may not run on the Kubernetes cluster for any reasons. But again, I would repeat again that we are a Kubernetes first approach company, and we have clients who thought that their workload will not run in the Kubernetes, but we have demonstrated that their workload can run. Now, I want also like to mention that many organizations, the fear that they do not have the right type of right skills, or the right employees with the right skills to run the or manage the Kubernetes platform. So that's another beauty of our platform, that it is masking the complexity of the Kubernetes technology itself, and it is enabling the the clients to run their workload on the Kubernetes without having them to kind of get the trained staff who have the Kubernetes knowledge. So we have, Rajat, we have clients, you know better than this, that we have clients who are running the workload in productions live with the 2 million users, and none of their staff has the knowledge of Kubernetes. So that's the
That's right.
beauty of the platform. So that's like it masks the complexity of the Kubernetes, and all you have to do is to focus on developing your application. That's your core IP. You know your business better. You know the technology that you have chosen to write your business, and kind of like the go live. You just focus on that. The rest all is taken care of by the platform. So on the right hand side, as I was continuing, that is the Kubernetes platform. It could be a managed Kubernetes platform in the cloud, AKS, EKS, GKE, whatever you choose, any cloud. The platform is truly cloud agnostic and it can provide the service. Or even if you have chosen the VMware Tanzu, OpenShift, doesn't matter, Rancher, whatever the flavor of the Kubernetes you want to use, we are perfectly fine and we can run your workload on top of that. Now, how do we do that? Let's switch back to the picture and let's just start going little in the middle. So our platform is sitting in the middle, AppZ platform, and this our platform comes with a built-in Kubernetes, but it can also integrate with any Kubernetes, as I said earlier. And the platform has a GitOps engine, which takes your code, and this code could be your application code, or this could be your configurations to consume the other cloud services. Like give me an RDS, give me an EC2 instance, give me a Windows with the SQL Server, whatever your need is, that you declare your need, or your applications into your GitHub or GitLab or any source control system that you use, Bitbucket, it doesn't matter to us. Our platform will pick up those changes and merge those changes with what we call AppZ templates, which is on the top, AppZ stacks. So we have hundreds of stacks, kind of like covering most of the open source technology. And if we do not have a stack which meets the technology that is in use at the client side, we can create the stack. That's our kind of like the proprietary way. And that customization that you saw in this demo, that we took the PG auto failover, layer our customization in terms of the integration with Vault, in terms of the observability, and also like how that PG auto failover will orchestrate from the deployment perspective as a stateful set, and the right type of pod assumes the right role, and all those things like we did. If you watch the previous webinar, you will see that only the first pod one becomes where all the databases are getting created, user getting created, and that gets propagated. So we took the technology, layer our customization on top of that to make it very simple to use. And you saw in this whole webinar, previous webinar and this one, that we are not logged into the Kubernetes cluster to do anything. Everything is getting done through the GitOps, and uh, the people who are kind of like doing the GitOps are either the developers or the operations people, the developers who are writing the applications, or operation team members who are customizing the either the cloud or on-prem configuration. So we are all about the simplicity. The AppZ platform is truly simplifies the management and the migrations of your workload to the cloud, and without having to train the staff on the complex technology of cloud, Kubernetes, Docker, DevOps. Like you don't have to worry about. You just focus on your applications code and your true requirement, declare them in a simple manifest file, AppZYAML, and we will take that and deploy or migrate your application to the cloud. I hope that's a short summary, but that's what we do.
That was. Thank you very much. I think we're out of time. Thanks for everyone who joined, and please, do if you have any questions, please do post on LinkedIn. We'll be happy to answer, and please stay tuned for any our future webinars. We'll be covering a few more sessions on Postgres in the coming weeks. So thanks for everyone who joined. Thank you.